I'm calling it example 2 because we did example 1 in period 1. And we're dealing with what happens when you've got your v squared, right? But you need to go further and find x, right? Now, if you want to get x, you're going to have to integrate again. But you can't just integrate v squared. You've got to integrate v on its own. So we're going to deal with that as we go through the question. Okay? So for starters, this is just the simple part. Using our result, let's see how good your memory is from before. We defined the acceleration, and we want it in terms of, not time, but displacement. Okay? And there was a derivative involved. So who remembers what's on the right-hand side? X double dot equals... Okay, the derivative with respect to x, right? Because again, it's all in terms of displacement and not time. The derivative of, now what was this awkward bit that was in here? It's about velocity. Half v squared, right? And you remember where it comes from, it's the integral of v, right? Without the constant we have to worry about, okay? Now, there's that result, and we proved it, okay? So let's use it now. We've been given an equation for x double dot, okay? So the way it begins is just by quoting this result and substituting for whatever results we've got. So I'm going to have on the left-hand side that derivative. And that's 3x squared. That's what they've told me in the beginning. Okay? Right, so at this point, I'm going to integrate with respect to x. That's what the right-hand side is, and this derivative is with respect to x. So I'm going to get my half v squared. 3x squared, integrating with respect to x, is going to turn into x cubed, right? By the way, can you see now why all those months ago I was trying to emphasize that we should write the proper derivatives, not just y dash, right? Because you're going to have all these different letters flying around, and it totally changes the meaning to differentiate with respect to one thing versus another when we get to time. Okay? All right, so there's our x cubed, and of course you've got to have your constant there as well. Okay, so far so good. Now, in order to get v squared on its own without this pesky constant in the way, let's simplify to get v squared there, which gives us this. And now, which details should we get to find out what the constant is? Well, I've got v, and I've got x, so I need some kind of condition that relates those together. So I guess I'd go with this one. The time will come into the picture later. Okay. So, therefore, velocity minus square root of 2. Okay, so this on the left-hand side is just going to be 2, because the negative will square out. And on the right-hand side, we've got 2 times 1 cubed. So that's 2 as well. So our constant is 0. And so now I can write my formula for v squared. It's just 2x cubed. That's all. All right. Now,